Hello guys, I am Professor Guilherme Baeta.
I'm in charge of this laboratory here. I'm the general coordinator here. And I'm going to show you exactly how the homogeneous charge compression ignition, so-called HCCI, works. Okay? For the time being, we are, let's say, conducting this research with ethanol. In the future, our intention is to go further than this and explore this combustion system, this advanced combustion system, operating with hydrogen and ammonia as well. Okay, this is important to us. Okay, I have here with me Professor Armador from Universidade Técnica Federico Santa Maria. We have a joint collaboration, okay, in a project here, and he came here to Brazil to work with us at the very beginning and see what we are doing here with ethanol, because now it's time to go for the ammonia and the hydrogen. Okay, so please come closer just to show them the screen here. So first of all, this screen controls the automate system. This screen here controls our ECU, okay? All the parameters needed to control the spark. And here there is no spark anymore because this is our ignition, but we have also here the control of the fuel and so forth. And there, in that screen, we have the combustion control, right? So let's start from the very beginning. So we have a transition from a spark ignite system to our ignition system. This is a bit complicated, let's say, to migrate from out ignition to HCCI mode. But I'm trying just to shorten the explanation to you to have, let's say, an idea how does it work. So first we start operating at spark ignition, and then we start, first of all, leaning the mixture. So we control the mixture. Here you see the GDI, okay, the gasoline direct injection. This is here is ethanol instead of gasoline. And duration of injection, DOI, okay? And here we control the amount of fuel that you put in the injector, right? So start leaning the mixture, okay? And then, as soon as you do this, we need to compensate the ignition timing that you see here. You see, map operation ignition. So we increase the ignition time because when you lean the mixture, the combustion takes place, let's say, in a slower mode. So it decreases the speed that the flame propagates, right? And due to that, so we need to compensate this in the ignition time parameter, okay? Simultaneously, we start decreasing the dwell time. This is let's say, the charge for controlling the energy to the coil, and then to the spark plug, right? And then by means of this, we start decreasing this. So we lean the mixture, and simultaneously need to compensate this by the ignition time. And to decrease this, first of all, we need to heat up the air in the intake. Okay, so just to give an example, right now we are operating at 93.4 degrees Celsius, okay, in the air, okay, this is in intake manifold, okay, this measurement is taken inside of the intake manifold, right, very close to the intake valve, right. So the most important thing is, so we control how the amount of heat needed, and then we, again, leaning the mixture, okay, compensate the ignition, and decrease the energy to the coil. Up to the time that we just take all the energy for the coil. There is no spark anymore. You see zero in the old table here, so there is no spark, right? And then the combustion is working here very well. I'm going to show you. So we control the amount of fuel, take out the energy from the coil, and this is not operating anymore, no ignition anymore, right? And then just the fuel. But as you can see here, please, we can see the pressure curve. So we have in yellow here, let's say the motoring pressure curve, and in red we have here the pressure with the combustion taking place. Okay, here we see the IFC, the intake valve closing, then here the EVO, the exhaust valve opening, and then we see here that around, let me see, if you see here, the MBF 50 is around 1, so which means 1 degree at the top dead center. We have the
combustion take place by our ignition here, but controlled in terms of the maximum pressure. And you see from the 10% of the mass fraction burn up to 9% of mass fraction burn occurs with only 4 or 3 degrees in the crankshaft. This is, let's say, very quick. And as you can see here, from 10% to 50% mass burn fraction, we have just 2 degrees of the crankshaft. And from the 50 to 9, another 2 degrees as well. So 4 degrees in the total for the developed combustion flame, right? So this is what we have. And here you can see the heat release, okay? And the rate of heat release here. And you can see that's the sharp curve here, the slope, sharp slope, very fast. We can burn everything. So we start the combustion in several parts of the combustion chamber simultaneously to burn all the fuel at the glance, right? And this way it's very effective because you did not, let's say, lose heat for the atmosphere as you lose in a normal combustion system like a spark ignition system. So this is what we want to show you, okay? And later we can give, let's say, further explanations during the symposium. Thank you for everything. That's all.